Assalamu alaikum and hello to the respective lecturers and everyone watching. My name is Ahmad Yasser and I'm gonna present my final year project presentation, which is about remote COVID-19 patient monitoring system software part. This is what I will be covering today, starting with the introduction, problem statement, motivation and objectives, followed by methodology, results and discussion, and ending with a short conclusion. Covid-19 is a new version of coronavirus which was first detected in Wuhan, China in the late 2019 and subsequently spread worldwide, causing the current pandemic. The earliest date of symptoms detected was on the 1st of December 2019. These symptoms were including fever and dry cough, which were why the virus was diagnosed as a viral infection. On the 12th of February 2020, the World Health Organization officially named the virus as Covid-19 when the whole genome sequencing results showed that the causative agent is a novel coronavirus. And on the 11th of March 2020, they finally announced that Covid-19 is characterized as a pandemic. Covid-19 spreads quickly between humans. The virus transmits from an infected individual to another individual via oral fluid droplets, mainly airborne, through coughing or sneezing. The problem currently is that the new daily cases in many nations are keeping on increasing by the time. Hospitals already are refusing the patients because they have no enough vacancies for all the patients daily. Consequently, these patients might either die because of lacking the right treatment or at least keep on infecting more people outside, which will do nothing than making the situation worse. The motivation for this project is to make the outbreak more controllable and manageable, to reduce the pressure on hospitals, to continuously monitor the patients with little effort, to put all the patients under eye and to save expenses. There are four objectives for this project. First is to carry out a comprehensive research into the design and development of the application that processes the collected data of COVID-19 patients and display the finalized details. Second is to create different versions of the application, one for the patient and another for the doctor. Third is to provide an appropriate real-time communication platform so that the patients can receive advices from doctors as well as reporting their progress to them. And lastly, to store this information in a database for tracking purposes. The methodology followed is as displayed, starting with the research and carrying out the literature review, followed by drawing an initial architecture of the system, then deciding the most suitable hardware sensors, generating the symptoms assessment, deciding the database and the frameworks, and finalize the features to be integrated in the app, and finally develop the software system itself. The system's architecture is basically some medical sensors to be attached to the patient. Those sensors are connected to a microcontroller which uploads the data to the cloud. The cloud then sends the data to the mobile application which is accessible by both patients and doctors. Sensors chosen to measure the vital signs are MAX 30102 to measure the heart rate and SpO2, LM75 to measure the temperature, a pressure sensor to make sure that the patient is in a resting mode while he is measuring, and the ESP32 as a microcontroller. Inside the symptoms assessment that the patient needs to submit daily, these 9 questions will be displayed and the patient needs to answer them all based on scale and weight approach. The weightage for each question are gotten from doctors who are exposed to COVID-19 patients daily. Firebase was chosen to be the database. It's a NoSQL type which was chosen because it's a real-time database, no cost is required, and can store enormous amount of data. It runs well on the cloud and easy to integrate with the mobile applications frameworks. For the framework, Android Studios was chosen to be worked with, along with Java language as the backend and XML as the front end. Android Studios was chosen because it's fast in the development speed, simple to work with, has a lot of features available, and it's a high performance. results, and discussion. This will be our finalized hardware prototype containing all the sensors chosen, along with the pressure sensor, the microcontroller, and a power supply. Now for the software development, we will have a walkthrough of the COVID patient monitoring system application. By clicking on the application's icon, an opening layout will be displayed for 3 seconds and then directly moving to the register page. We will register a sample patient user, so we will enter a patient role. When clicking register in the authentication page in Firebase, we can see the new registered user. From the Cloud Firestore, we can also see all the information for every registered user. And as noticed, we can see the patient's name in his home page. Starting with the first feature of the application, which is the vital signs, the application will automatically retrieve the latest measurements from Firebase. The patient will need to click Insert Data button in order for these data to be uploaded in the data set, and for the patient also to see when is the next measurement, and that's based on his condition from the SpO2 side. Moving on to the symptoms assessment, these 9 questions should be answered daily by the patient according to his condition, and then click submit. The application will automatically upload the data to the cloud and also calculate an overall risk percentage based on the scale and the weight. Patient can access his medication in order for him to see if there are any updates from the doctors. The list includes all the names of the medicines along with the doses and how to take it. The patient has another feature which is called Get Help. The patient can either communicate with doctor via online chat or video consultation if the case is not that severe and he only needs to show something to the doctor, or for emergency cases, the patient can call for assist or directly order an ambulance if the case is very dangerous. Now we will go to the doctor's version of the application. Let's log in. When the doctor log in, he will be asked to choose from a list of patients which patient exactly he wants to access. After clicking on the patient's number, the application will direct the doctor to his home page, and we can also see that the name of the doctor is written in his home page. By the time he logs into the application, if there are any severe measurements from the patients, he will get a notification for it. Now the application notified the doctor that there is a severe measurement detected because the temperature is now 39 or above. He will also be notified if the SpO2 went below 95. When the doctor accesses the monitoring vital signs layout, he will be able to see 3 graphs for average heart rate, SpO2, and temperature. Each graph will show all the measurements taken by this patient, and we can see they are matching the data in the Firebase. And that's basically for monitoring purposes in order for the doctor to see the patient's progress. Now for tracking the vital signs, similarly there will be a graph that shows the overall risk percentage. If the doctor wants to know more details about a specific measurement, he can enter the scale number and click submit. The application will then show him all the inside details about this specific measurement. The medication feature for doctors is that they can edit, delete, or add the medicines, which will be directly reflected on the patient's medication layout. Now the medicine called zinc 50 milligrams is deleted. I will also show how to add a new medicine. Now the new medicine is added to the Firebase. That will be all from the application side. In conclusion, implementation of the remote COVID-19 patients monitoring system is an urgent need for the current pandemic in order to make the situation more controllable and manageable. The system will surely reduce the pressure on hospitals and spread a relaxed environment for both patients and doctors. Both software and hardware are complementing each other. The hardware sensors were proven to be the best suited for measuring the vital signs, and the mobile application will compensate those other symptoms via the symptoms assessment, resulting in an overall homogeneous system. For future enhancements, we can develop the software system as a cross-platform native application such as Flutter in order to run the application on Android and iOS. We can also implement a respiration rate sensor. We can put a GPS tracker or add some other features in the application itself like medicines alarm. That will be all from me. Thank you for listening and stay safe.